continue how to choose the right amount of memory session. Could you give us an introduction of yourself, Radovan, before you start? Thank you.
I'll be happy to. So nice to be here. Nice to see you all. Radovan Bast from University of Tromsø, where we are getting less and less light by the day. Working in high performance computing since, like professionally, I would say since 2013, almost 10 years ago. Also, I'm really interested in the software side of things. I know not so much about the hardware side of things. I will try to I will talk here about choosing memory, also then how to choose the number of cores. So that's the plan for the next 2 hours. There will be exercises. Also, I would love lots of questions, both from audience. Best way to ask questions in this is in this document right here that we see in the md.sigma2.no, etc. I would also love some questions from colleagues, but who is now with me now here? Who will ask me questions and discuss with me? Is it Sabri still, or is it Jan? Maybe it's just me.
Okay.
I'm here.
Okay. And
I'm also here for later.
All right, so there's Björn and Jan. Excellent. So please,
Yeah, I'm also here.
Super. So please comment, ask questions, or fill in where I blank out. Good, let's start. Before we go there, I will have a question to the audience, but maybe you have noticed that the screen has changed a little bit. I will use this portrait mode. The idea is that you can do something else on the other half of your screen. So the best way to participate is to make the Zoom window half of your screen, and then on the other half you can open up a terminal, because some of the things, so then during the exercise, or if you want to test these out, or if you want to read more about the content. So that's one thing I wanted to say. The other thing I wanted to say is that this morning we heard about what we should do and not do, and how to be responsible users. I also wanted to comment that sometimes it's not the user, sometimes it's the staff. So yesterday Saga was really slow, yesterday evening especially. I noticed that when preparing the session, but in this case it was not the fault of users, it was us running really heavy backup on the machines. Good. Now I have a question to everybody, and I will ask it here on the collaborative document. And the question is, I will ask it under 8. Question to all. Also, let me know if my voice is not clear, or if the font is too small. I can zoom in. Question to all. How do you, so you can vote here. I run code that I wrote or co-wrote. And you can vote by adding this little O behind it. Or maybe I run code written by others. Or I just module load and run the thing, which is the same as the one above. Load the module. So please let me know.
Radovan, I use a lot of Conda installed software. What should I do?
So this is also then written by others.
Okay.
And I will give us a moment to answer. And we have 33 people online, but 12-ish answers. Also, if your answer doesn't fit in there, you can add a new answer. Let's see. So that's interesting. We have half the participants write their own code, or they they write code with other people, and that's what they run on the machines. I think those of you who do that, you probably know what the software user needs in terms of memory and in terms of cores. I say probably because sometimes it's difficult to predict. But here, at least, you probably have an idea. For those of you who run code written by other people and maybe don't even have access to the source code, it can be very difficult to tell. Does it even run parallel? How many cores? How much memory does it need? Maybe it's documented. Very often it depends. And I think this is the motivation for this session, is that it can be really hard to tell, even if it is my own code. And I want to show you some tools that I use to find out how much memory we need, how many cores we need, and why does it even matter. Maybe we can start with the question, why does it matter? And I want to show you an example. And now you don't need to do anything, you can watch. You will do a similar exercise in a bit. So for the moment, only watch. I will type here, I'm on Saga. And let me know if the font is too small. Whatever I will type, it will also, all the commands will show up down here. And in here, I have a little mystery code executable, which I got from somebody. So I'm part of the people who now I'm writing code written by others. So this is a code that I got from the previous PhD student postdoc. I want to run it. I have this run script. And now what is in the run script? In the run script, now we have, this is our account, our reservation. I don't know how long it will take, but I will start with 1 minute 30. And now we need to decide how many tasks. So on how many cores is this supposed to run? And how much memory? Now until 11 o'clock, I want to focus on this one only. After 11, we will then talk about this line. So let's focus on this. How much should I take? I don't know. 1500 megabytes sounds good. Let's test it out. I will submit. Let's see if this is still running. It's already over. That doesn't sound too great. So it stopped. Now I got an output file here. Let's inspect what is inside. What is inside? Lots of numbers, lots of zeros. That's never good. But there is this OOM kill. There is also out of memory handler. So I wanted you to, if you see this in your output file, now we know what that means. It means that we ran out of memory. I asked for 1.5 gigabyte. That was not enough. Slurm will give my job a certain amount of memory. It tried to go beyond. It stopped it 2 seconds into the run. So what to do now? And I will watch here the collaborative document. I'm watching it on my other screen. So please keep questions coming. I would love to see lots of questions. But what can we do now? Anybody has an idea? I will edit. So when I type Vim, that's my editor. I will edit the run script.
No, I mean, you could add more memory per core or CPU.
Exactly. So that's what I think everybody will do in this situation. Well, maybe you would either send an email and ask what happened, or you would give more. And how much should we give? I don't know. Let's be on the safe side. Let's ask for, how about 6,000? Let's do it. 6,000 it is. Let's submit again. As batch, now it will hopefully not crash. It's running. I think it will run for like 30 seconds, 35 seconds for a certain reason, which I will clarify.
Radovan, could we also instead use just memory in total? So for the whole node, or do you always have to do the calculation per CPU core?
Great question.
Because that feels like always a bit weird. If like I ask for 4 cores and then I want 12 gigabytes, so I have to divide it by it. It's always a bit like clumsy, I think.
Yeah, so I like this per CPU because then if I modify later, if I go to more CPUs, I don't really have to do any math here. Also now I'm on Saga where we have to specify this. It's different on different machines. On Fram, you typically should not specify this because you will, unless, so there is a lot of except unless we need to, it's good to check the documentation. It depends on the machine. So on Saga, we have to specify this. On Fram, typically not, because on Fram we get a node for us, as far as I understand, and the node has a certain amount of memory. On Fram, you only need to specify it if you are on a high mem node. Yeah, and there are different ways, so you can do per CPU, per node, per the whole job, but I like this one because then I don't have to do so much math. Did that finish now? Let's see. It finished. And in this case, if I would now look at the Slurm output, which I will not do, it ran successfully. So now we can be all happy. But what is the problem here? Possible problem that I did? And why does it matter? I asked for, just to be on the safe side, but is that always a good strategy?
I think as we learned yesterday, it can happen that maybe you just needed 2 gigabytes instead of 6, and now you asked for way more, which would mean that it's harder to squeeze your job in, and you will also be billed for more, I think.
Yeah, these are good points, because typically every core has typically 2 gigabyte. So if I here ask for 6 gigabyte or 6,000 megabyte, I will, in effect, I'm actually occupying 3 cores, because 2 of the cores, they do nothing, they just donate their memory. And now it's maybe a good moment that, how can you find where, so if you then follow on the document this link, you land on a nice documentation page. Well, let's make this larger, which is in our documentation.sigma2.no. And how can you find it if you didn't have that link? How do I find it? It takes a couple of clicks. Maybe we should make it more visible, but the way I go in there is I look for jobs, running jobs here, high performance computing, running jobs, click. And then we have here how to choose the right amount of memory. And a little bit later also the other one. So in there, and let's zoom in even more. Yeah, it's really good practice to not ask for a lot more memory, and the reasons are, why does it matter? You can get charged too much. You can also wait longer for your jobs to start because the queuing system thinks that you need a lot of memory. It's not available, so the job needs to wait until the memory becomes available. So maybe you have to wait longer. So this is not a problem for everybody else, but this is a problem for you. No, other users, this is a problem for everybody else. Because I reserved now all these cores that do nothing and nobody else can use them. Oh, there's teaching going on. Ah, good chocolate, thanks.
So you got home delivery.
All right, thanks. Yeah, thanks a lot. That's so nice. So this is a problem for others, but it can be a problem for me, more queuing. Also, if you want to parallelize your job in terms of we can use these Slurm job arrays, run lots of jobs at the same time. I may limit myself by asking for a lot of memory because then there are not so many cores available. All right, so we now understand it's good to have an idea how much memory we consume. How do we find out? And I'm catching up here on questions. How can we find out?
I would suggest you can just like run it with too much like we did now and then actually check afterwards. But you still have to show me how it shows how to, where do you actually can find information, how much it used.
Yeah, so that was a good one idea is that I could be reducing this until it crashes. That's one way. It's a not very elegant way, but I have done that in the past.
Yeah, it can
Or-
also take a while, I guess, if
Yeah.
it's not directly at the start.
So is there a better way? And there is a better way. There are a number of better ways, and they are all listed here on the page. I will not show you all of the different ways. I think I want to show you maybe one or two. And then there will be an exercise, and you can try this out yourself. So you will get this mystery binary, which I compiled for you. And your goal will be then to find out how much memory it consumes. Maybe let me show you two ways. Where should I start, Jörn? Which?
I mean, we talked already about the output script, I think. So maybe just like,
Yeah, let's look there.
everyone gets that if you don't like delete it on purpose.
Yeah, where is
Maybe.
it? It's this one.
I think it should be the out.
So the older one, what is in there? Here we have some numbers. This is the output that comes from the binary. Everything went well, good. And then there are lots of numbers. The number that is interesting in our case is this one here. It says 3 million kilobyte.
How do you know? What does FRSS mean?
It's a really good question. I mean, I know the abbreviation means average residence something size. I don't know. I don't know what the difference is between this and this one, because I'm always interested in what is the maximum memory that was ever used, because it will never go beyond that. So I'm looking at this number. In this case, it's the same, and it's, how much is that? 3 million kilobyte, or 3,000, a little bit over 3,000 megabyte, or a little bit over 3 gigabyte. So the writing here, what should I have asked for? In this case, maybe 3.5. It's good to ask for a little bit more. I typically add like 20%. But since you asked, this may not be really nicely accessible to everybody. So what I like to do, I like to remember my job number. And once the job is finished, I like to do Ceph, Slurm efficiency checker. And here I can see the information as well. Memory utilized a little bit over 3 gigabyte. The other thing I could do is I could start the job. Maybe I can do that just for fun. Let me SSH saga.
I also have to say this, the advantage of Ceph, which is Slurm efficiency or something, that rate, is also, it actually tells you memory and not RSS, which is like an abbreviation. I still forget, like all the time as you do, what it actually stands for.
Yeah. So one thing, the other way we could do, I could submit it. Let's submit again. And how do I type so fast? I did this Control R. So then this is like what Ole did yesterday with the exclamation mark, but I can see the command before I hit enter. Let's submit. And I have now 35 seconds to find out where is it running. It's on this node. Let's log in, SSH. Let's go to that compute node. Fingers crossed. Come on, quicker. Time is running out.
Run process, run.
And what I plan to do here is to run a top or htop in that compute node.
I think you could actually already write it. And
so that was maybe another great example, but I could, oh yeah, here we go. No htop, but there is top. And if I'm quick enough, here's my job. And where is the memory? This one, approximately 3 giga, and it's already gone. But this will be a way to, I know it's there again. No, it was top.
This is top, what you're looking at.
I think I was too slow. Okay, so somewhere there was a time window to find out how much memory, but let's forget about that. That was maybe not the most elegant. Also, if you have a job that runs overnight, you don't want to wake up at 3 a.m. to find out how much memory it was used. Maybe one more that I really like, and that is what I like to put into my run script is, and it's mentioned on the documentation, is in front of whatever I do here, in front of it I type USR bin time -v. It will not only tell me how much time was spent in this portion, and I don't need that information anyway because Slurm knows it, but it will give me a little bit nicer output. Let's try it out and let's see what we get. We will get a nicer.
So time doesn't give you the. It doesn't give you actually the time. It's more like in Python, so like a time it or like command.
Yeah. So this is this thing is not the same thing as writing time. But now if we wait 35 seconds, we will get a really nice output, and I don't even have to wait so long because we have it in our documentation. So re-photo scrolling, but I want to show you how it will look. Here, this is what I did. And in your Slurm output, you will get this nice summary. And the interesting line is this one then. Ah, that's what it meant. Resident set size. So now we know what that means. Max RSS. What is good to know about Slurm? What is good to know about Slurm, information from Slurm OSEF, is that it samples it every 30 seconds. Which means that if you allocate a lot of memory just before the 30 seconds or just after, Slurm might not see it in your output. Also, if your job is shorter than 30 seconds, it will tell you that it allocated 0, which may not be true. So that's also good to know.
But Slurm would still kill my job, even though it samples only every 30 seconds.
That's right. So let's go to the. I wonder whether I should explain any more or whether let's explain what the exercise is about. The exercise is up here. This folder here. So what you can do, and now you can do that with me. So you log into Saga wherever. I will make a new folder for the HPC course. And I go into the folder, and then you can copy the exercise into your home like this. And in this exercise, there is this mysterious binary. There is also there are instructions on what to do. There is also a spoiler. So if you get stuck, or if you want to verify did this work out, you can have a look at the spoiler. And what is in the instructions? In the instructions, well, copy this folder, run it as it is, and it will fail. And now we already know the error. You will run out of memory, then try to increase the memory. Does it still fail? Hopefully not. And then try to find out how much memory is really consumed and take the method that you like best. If you have time left, you can also try that on one of your own programs, and have a look what it tells you. And the way to participate in these exercises is we will give you 15 minutes or more. So if you need more time, let us know on the document. You can write there. And you can either join a breakout room. So on Zoom, in the Zoom window on the bottom, there will be join breakout room. In the breakout room, you can ask questions. Nothing is recorded there. You can share your screen. If you prefer to work on your own, you can also stay in the main room with video off and then ask questions on the collaborative document. And then we would be back, and we will then, hopefully we get lots of interesting questions that we can then discuss back here in the main room 15 minutes later or more. So again, step number 1 will be, and is this thing, go on Saga. Maybe I should clarify that. Where are we? So on Saga, copy the exercise folder, go in, and then join a breakout room.
I took it a different approach. I run multiple times, and I see that there's a difference in the numbers you get for each run. So there's something strange going on. They don't report the same number for every run.
Yeah, that's interesting. Hopefully they are still in the same ballpark.
Yeah, then the first digit are the same. The three last one is 672 for the smallest one and 868 for the biggest one. So there's significant difference.
Yeah. And so we got a couple of questions about both difference between what we see from Slurm and what we see from this US Arbin time. Also, we got a question about difference between what we see from what we ask Slurm and what we get from Ceph. So there are slight differences. I don't really know why that is. There are some ideas what it might be, but also really nice analysis by Ole that by running several times, we get different answers, which is interesting because it's always the same binary. The good news is that we don't have to be worried about that because we will not ask for precisely that amount of memory. That would be very dangerous because what if I need 1 kilobyte more after 2 days of running and then Slurm kills it? So what I do in practice is if I know approximately how much it needs, I add a bit to it, 15%, 20%. Just please don't add 2000%. It's a good idea to add a little bit more. Maybe we can also discuss what if you need more than the core has. Well, you can ask for more, and then the scheduler will spread your calculation over multiple cores, and the cores will donate them their memory. But you might get, so you will get charged more because you will block these cores from being used by other people.
Yeah, how can I find out how much one core basically has?
Yeah, how can you find out? You tell me, but one way you can find out is you can check our documentation and look at the hardware pages. Let's see whether I can find it. So here we have overview, Saga, let's say. So here we have some information.
What are these big mem nodes, and how we know that whether we should use the big mem nodes or something like that?
Yeah. So I will answer both questions here. Let's go one by one. How do we find out how would you do it? Like I can read here, but how it depends. So I can divide this by 40, and then I know how much is on a core. Or how else can we know?
That's the one I do.
Yeah.
Me too.
Yeah. You could again, if you know the node where you're running, I mean, I could submit a job, SSH to the node and run top there. I will see how much memory the node has. I'm sure that there are many other ways to find out. I think if you need much more than typically, does it even make sense when I said 2 GB per core?
No, it's around 4. So in the case of 40 cores, it's like 4.8, and with 52, it's 3.7.
Okay, so there are 4. I'm living in the past, so if you need then much more than that. So if I see that I need quite a bit more than, let's say, 5 GB per core, process, thread, task, rank. I know these are lots of names, but it depends what we are running. If I realize that I need a lot more than that, it might be a good idea to go to these big memory nodes. So what is a big memory node? It's like it's a computer node, but it has a lot more memory than that. So here we have 3 terabyte memory. That's so incredible amount. And then you can go here.
Yeah, or to the medium, like where you have double the amount.
Yeah, so let's go step by step. I didn't see that even. So I would go from here to here, and if I need a lot, then here. But we should also not go to the big memory or medium memory nodes just because the queue is shorter there, and so I should only go there if I really need the memory. I should not go there just because nobody's using it. That sometimes happens. And it has happened in the past that somebody was using a big memory node blocking for everybody else. Then we found out that the job doesn't actually need any memory. Then we reached out to the user and asked, well, why do you ask for, I don't know, 20 gigabyte here? And the user said, well, I don't know. I got the script from my colleague. I don't know what these things mean. And I perfectly understand that. But what is good is that now we have a mechanism to find this out, to calibrate it. And do we need to, the thing that we did right now, do we need to do that for every single job? No, you only need to do that until, I mean, it's like, yeah, so until you get a feeling for the code that you are using and for the system size that you are using. It's only when I move to a different machine, different code, different system size, different input that I'm unfamiliar with, only then I will calibrate this. But now, if I want to run 200 similar jobs, I don't need to check it for each of them. I know that each of them will consume around 3 gigabytes. I can submit all of these 200 jobs and everything will be good.
You know, the advantage of Ceph is also that it's quick and easy afterwards to just if you change the bit, maybe you have a different protein input or something, you can check if it's still in the ballpark.
Yeah. And what I didn't say here is that Ceph really only works well if the job is finished.
Mm-hmm.
I think if the job is running, then it might give some weird numbers, just the way it is working. And I think it's not a problem to submit one job and complete one job which didn't use the resources well. But then we look at it, we adjust, and we go from there. When doing this calibration, it may also be a good idea to go on the development queue. Because for me, that's calibrating a run script is for me development work. And then once I know what parameters do I need, then I don't go anymore on develop queue, then I go on the regular queue.
And there is a question, how do you specify which memory nodes, big mem nodes or medium nodes you should select?
That's a great question. And it will test me how I can find this in the documentation. I know we have it documented. Let's see. Running jobs, I would probably go here. And now with job types, job scripts. Let's see.
Types, I think.
Job types.
But this is in general also a good moment to say the documentation is not perfect, and if you feel that there's something either missing or you can't find it, or you could find it but it took you forever, you can also just write us, and we will try to find a solution, because everything here is work in progress and will change over time.
Job scripts, big mem, here's the one. So that's how, but we know it took a couple of clicks. It took me knowing where this thing is. Our ambition is to have really amazing documentation that is easy to browse. It's a process. Good, and I will answer that then in writing.
So you have to add this line, this S-batch partition big mem, and I guess you will either, depending on how much memory I ask, you will probably either end up on the big mem or the medium, so the super large or the medium large memory.
And this medium memory nodes, that's normal partition jobs, right?
No, they are also big.
Is there any partition specification for this medium memory?
No, I don't think.
Let's see.
Well, go to big mem again. And then you will see here the available resources. You have one of the two. I think if you ask for a lot, then you will end up on one of the 8 nodes, which of course can be quite busy. And if you ask for more than anything else, you will end up on the smaller ones.
Super. How about we take a break, and after the break we talk about the course, not about the memory. Now we know about the memory.